Excellent. All right. Thank you, everyone, very much for your patience on dealing with a few tech issues just as we're getting underway with the webinar. So really excited to have everyone join today. This webinar will be recorded and made available afterwards for anyone that missed it. So welcome to the low methane sheep webinar, where we're excited to be releasing the first round of publicly available project breeding values. For those that don't know me, I'm Peter Bradley. I'm the Genetics Business Development Manager here at Sheep Genetics. And if I could jump to the next slide, please. So just some general housekeeping before we get into today. Noting, as I mentioned previously, this webinar will be recorded and made available afterwards. There will be a copy sent to everyone that had registered for the original webinar. Just please make sure if you're not speaking or asking a question, that your microphone will be muted. And there's going to be opportunities. We're going to hear from both Daniel Brown, Michael Aldridge, and Julius van der Werf today. We'll go through those sections, and then we'll have a really good opportunity for Q&A at the end, where you'll be able to either come off mute, or if we're going along and you've got a question, please pop it in the chat. We'll be monitoring that, and we'll make sure we ask that of the most appropriate person. So the format for today, welcome and introduction. I'm going to then hand over to Daniel Brown and Michael Aldridge from the Animal Genetics and Breeding Unit. Daniel and Michael will cover an overview of the projects that we've had and currently got running around collecting methane records, a deep dive into the analysis of those records, and then the next steps. Where are we on our journey towards methane breeding values? Once Daniel and Michael have gone through those, we'll hear from Julius from the University of New England around, we've got breeding values, but what are the considerations that we need to think about as we move towards adding methane into our breeding objectives, and what does that mean for selection? And then we will move into questions. So before I hand over to Daniel and Julius, the purpose of this webinar, as well as to get an update on the research, but this is really our launch for project breeding values for methane, which we'll hear as a result of a couple of years now of recording and analysis. But at the end of the webinar, we'll be going through and you'll all get access to our new booklet for project breeding values. So that's really what we're launching, and we're going to find out a little bit more about the analysis and considerations for selection as we go through today. So without holding you up on any further on the introduction, I will hand over to Daniel. Daniel Brown, over to you.
Thanks, Peter. So as Peter's already highlighted, this is a culmination in a long journey, and there was a extensive project that's been running for a number of years now that Julius has led through UNE with a large number of collaborators across a range of organisations and also with industry. So this has been a really important investment, and the results we'll talk about today and the reports we're producing is an outcome of that collaborative project. So I just wanted to also mention that we've also pulled together some historical data to be contributing to this process. So some data collected over the last 20 years has been included in this data set and brought together to inform breeding values and the research going forward. And furthermore, since this project started, there's actually been a number of other important collaborative projects developed alongside, which we won't talk about today, but in particular, the sheep CRC, the Net Zero CRC is also now actively collaborating in this space to record these traits, as well as another international project funded by MLA and the Global Methane Hub. So there's actually quite a lot of collaboration going on, which is good to see, and it will only improve on what we're trying to achieve with this original project. So I guess at a high level, the main aim of the project was essentially to develop a reference population for methane as well as feed intake. So we've been actively measuring animals now through portable accumulation chamber for a number of years, and genotyping those animals across a range of breeds and range of flocks to really grow that reference population for both R&D purposes, but also to give us the ability to do genomic prediction going forward. And that essentially is what you're getting now in the project breeding values, is essentially genomically assisted breeding values coming out of that reference population, which will only continue to build. And that obviously includes feed intake, which is a key trait which is related to methane. So just at a high level, progress updated where we're actually at. So essentially we've got about 18,000 animals now measured for methane across a range of flocks. About 35% of those are resource flock lambs from a range of breeds. We also have measured a number of drops that come out of the Merino Lifetime Productivity Project funded by AWI, which have been very informative for merinos, as well as a large number of industry flocks, like some of the people on this webinar. So it's a good mix of breeds and flocks from right across the industry. We've done a range of analyses of that data, which Michael will touch on, to estimate heritabilities, to look at our ability to do genomic prediction and how well it works, and also look at correlations between traits. We're still working hard in the feed intake space. We do have about 1,600 records collected now, but aiming to have nearly 2,000, about 2,000 by October. So as we mentioned, we are releasing project breeding values right now, and we'll talk about the pathway to RBVs and ASBVs later in the webinar, which will be the more routine delivery of breeding values to industry. And as Julius will talk about, there's been a lot of time spent thinking about the trait and how to actually include it in our selection programs, and Julius will talk about that much more, but it's been an important part of the projects to date. So on that note, I'm going to hand over to Michael. So Michael's done a lot of the actual R&D work and analysis of the data, and he's going to talk through where we're up to with that.
Excellent. Thank you very much, Daniel, and look forward to hearing from Michael. Just a quick reminder for those that have joined during the introduction that this will be recorded. We'll have the link to access the project breeding values, which Michael's going to describe the analysis of at the end of the webinar. And just to ask any questions that you've got, there'll be Q&A for all the presenters at the end of the chat. So if you do have those questions, please keep them coming through and we'll monitor that. But over to you, Michael, to hear all about the analysis of the project breeding values.
Thanks, Peter, and thanks, Daniel. Well, I have done a lot of work in this space, but I couldn't have done it without a lot of help from a lot of other people. So I really want to make sure that I thank them as well. So big shout out to everybody that's helped along the way. The work that I'm going to present today really sort of focuses on what's been done in the last 6 months or so, and sort of following into what still needs to be done to go from that shift from project breeding values into research breeding values and one day ASBVs. So the current analysis, well, a lot of the work that you'll see today, if you joined the webinar that we had last year, follows on from that a little bit. So during that webinar last year, we presented some breeding values for merinos only, and that included around 5,500 animals that had been phenotyped within the project. We've had another 1,500 animals to that, and the heritability has stayed the same at about approximately 0.19. In the meantime, we've also seen a large increase in the amount of multi-breed animals that we've got. So we're now at a space where there's enough animals to be doing proper parameter estimation for those. So we've got over 5,000 animals in this analysis, which represents 17 breeds, and that includes maternals, shedders, and a small number of terminal composites as well. And we say that we get a similar heritability with the multi-breed as we did to the merino. One of the things that I've been working on at the moment is combining all that data together into a full analysis. So at the moment, this includes approximately 12,000 animals. We do have more data that's currently been collected. It's going through the processing steps at the moment. So the idea is to add that to the analysis as well, which will push us up to 16, 18,000 animals before next couple of months, I guess. What we do see, though, is that we have a higher heritability when we do this full analysis. I think that's something to do with a bit of the population structure and the extra variation that we add with, including the merinos, with the multi-breeds as well. So it's just something to keep our eye on at the moment, and we're investigating that a little bit further. Next slide, Daniel, please. So I'm going to talk a little bit about the project breeding values that we have at the moment. What you're looking at here is the distribution of project breeding values just for the resource flock. First thing to look at is that you'd expect that this should be a little bit more normal, but it's a little bit skewed at the moment. That's based on the fact that we've included all the multi-breeds in this analysis. One of the things to keep in mind as well is that really these project breeding values, because of this, is really should only be used for selection within flocks at the moment, or ranking within flocks, until we get to a point where we can do a better analysis across all of the flocks. What you do want, though, is an animal that produces less methane. So at the moment, that's a negative EB project breeding value for methane, and the larger that negative number is, the less methane you expect the progeny to produce. The handbook that is being provided at the end of the webinar, I've looked at the top 10%, but I believe the handbook looks at the top 20%. But we do see that there's size in pretty much every flock that are in that top 10%, and that there's no real flock at the moment that is. I can answer that now too, Rob, that at the moment, these are milliliters per minute. So because we only put the sheep into a portable accumulation chamber for 40 minutes, it's only a snapshot in time, so a spot sample of the animal. We see our New Zealand friends extrapolate this out to grams per day. At the moment, we're just being very specific about the fact that we are actually only recording these animals once in their lifetime for a short period of time. However, the conversion to grams per day is pretty much 1-to-1. It's just erring on the side of caution at the moment. Next slide, thanks, Daniel. One of the things that is important to keep in mind as well is that I mentioned how we've really been focusing on the fact that these project breeding values are within flock ranking tools at the moment. And we want to shift over to being able to compare across flocks. To do that, we've been looking at the genomic prediction validation work. What we do see is that in all the flocks, the vast majority of size, over 90% of the size in every flock, have a accuracy above 40% for their project breeding value. And we also see that the current selection candidates also have reasonably high accuracies for those within flock project breeding values as well. On the side of the validation work that we've been doing is basically trying to work out, if you don't have any animals in your flock recorded, how well can we predict breeding values for that flock? So what we do is we basically do an analysis with all the data, and then we do an analysis with one flock removed. And then we repeat that for all the flocks. And some flocks we do a very good job at predicting the breeding values for those animals. And in some cases, we do a not so great job. This is probably due to population structures and linkages between the flocks that we've recorded, but that's one of the reasons why we continue to collect data as well and refine the analysis. I think that it's interesting to note as well that those breeders that had reports back in 2025, we've included your flocks in the current analysis as well, obviously. And we see that within flock correlations of those breeding values for 25 to 26 are very high, basically no re-ranking of animals at all, especially in the top end. Next slide, thanks, Daniel. The other work that I've been working on is that obviously we don't just want to select for methane. Methane is just one part of the equation. What we have here is on the diagonal, the heritabilities for the traits for the data that I've included in the analysis. Below that diagonal, we have the genetic correlations, and above the diagonal, we have the phenotypic correlations. you just press the button, Daniel? First thing I want to hone in on is the genetic correlation between methane and our growth traits. So here I've only included a small snapshot of traits, but we've got weaning weight and adult weight. And we see that we've got a relatively moderate correlation here with our production traits, which we expect that larger animals eat more, animals that eat more produce more methane. So this isn't a concern, it's a good thing. It's what we expect to see. If we look at the carcass traits, so we've got yearling eye muscle depth and C-site fat depth, slightly negative correlations here and slightly positive correlation with greasy fleece weight. If we look at the fiber diameter, sorry, Daniel, we see that there's a very low correlation here, and with the standard error included, pretty much 0 as well. So no relationship with fiber diameter. Had a bit of trouble with the worm egg counts, but from what I've got at the moment, again, a low negative correlation. We are working on improving that analysis there as well. And with our reproduction traits, we see low correlations with methane. So I'd say that all of these correlations are within the estimates of other groups around the world as well, but a little bit on the low side. The analysis that I'm doing at the moment is work that's trying to shift from those project breeding values to RBVs. So I mentioned already that one of the things I'm working on is that full analysis. So at the moment, that includes the 12,000 phenotyped and genotyped animals within the project that we're working on at the moment. But there are new phenotypes that have come in, which will also be added to that analysis in the coming weeks. What we would like to see is that does this extra data improve that prediction accuracy, especially for those flocks that had a low genomic prediction accuracy that I mentioned in a couple of slides previously. I also talked about those genetic correlations, that they're a little bit lower than expected, and we've got moderately high standard errors on those. So we're also hoping that with this extra data that we improve those genetic correlation estimates as well. And to do that, we've got those extra phenotypes coming in from the Zero Net Emissions Ag CRC and the Global Methane Hub's Clean Breeding Project as well. The good thing about that as well is that we're also looking at analysis at the moment, where we've got some international data that's already been provided from New Zealand and Uruguay. We're hoping that this can help improve that prediction accuracy as well. It is a very difficult trait to measure and expensive, so it's one that we can work with the collaboration. Daniel also mentioned as well that within the other projects, that feed intake data continues to be collected. One of the things that I do in my analysis is try to correct for did the animal eat more than expected in the lead up to the methane recording, and we're hoping to improve that correction with that extra feed intake data that's coming in as well. It's not correcting for feed intake, it's just a very small snapshot of did the animal eat more just before it was recorded. Next slide, thanks, Daniel. I'm not sure, did you want me to cover this, Daniel? Yeah, so one of the things that was mentioned as well is that some of the work that I did originally when I first started was to start collating all the historical data that's been collected over the last 20 years from previous projects. We have that now in a single data set. It does add some challenges in the analysis though, in that there's a limited number of animals that are genotyped within those previous projects. And some of the gases that were recorded aren't exactly the same as what they are in the current one. So we can't get that feeding level that I talked about, that correction for feed intake just before recording is very difficult to do with that historical data as well. But we do hope that it will improve the genomic prediction accuracy if we do include those as well. But it's work that's ongoing. Talked a little bit about the correlations with the traits that we have at the moment. But really, methane is a key trait with feed intake and body weight. That we see these three traits or three groups of traits to be highly dependent on each other. And we do hope that selecting for methane also leads to improving feed efficiency of your flocks as well. So the idea is that as we collect more of that data, that we can include a multi-trait analysis of those together. As we go forward as well, I have been working on that multi-breed analysis at the moment. So that'll be wrapping up shortly, I hope. you see the most recent results for that in the handbook. And yeah, we're hoping to see that we'll get to that point within the next year. And Julius will talk a little bit about how we're not just going to be selecting for methane. Methane's one part of the story. So that'll be explained a little bit, Julius, as well, but that's the next step as well. Thanks, everybody.
Wonderful. Thank you very much, Michael. Good to see some of those preliminary correlations and heritabilities, but also that pipeline as we move over the next 6 months. I know we've got a lot of work ahead of us from both sheep genetics, but also yourself and the Agbu team to really take these project breeding values and make them RBVs. So exciting to get a look at them today, but I think when the RBVs come, that's really when the rubber hits the road. Just a reminder to keep the questions. If you've got any questions for Michael, please pop them in the chat, and we'll get to them after we hear from Julius, who's going to talk a little bit more about selecting for methane efficiency and some of the considerations we have to make. So I know we did start late, but we estimate we should be still finishing around the 2 o'clock. We've got about 15 minutes or so here with Julius. So before we get into the project breeding value, so over to you, Julius.
Thank you, Peter. Can you do the next slide, please, Daniel? So, yeah, I just want to talk about the problem. We have now a new EBV for methane. What are we going to do with it? The best we can do is to just look at the different options we have. So, next slide, please, Daniel. So, I think if you approach it simply, we have already breeding values and an index for dollar value at the moment for our animals. So what happens if we add methane EBV to it? So you see here in this plot on the axis on the vertical, you can rank animals based on the index, but those same animals can also be ranked on methane breeding values from left to right. And so typically what you see is there will be a slight correlation between them. So animals with a higher index probably have higher EBVs for methane. And the EBV of methane is expressed, I assume, in grams per day. The average should be around 26, 27 or so. So which animals are we going to select if we plot them on a picture like this? So ideally, we want animals that are in the left top corner. Maybe, Daniel, you can put your mouse on it, but we want animals there. If you can move your mouse to the left top corner, Daniel. So we want animals in that space somewhere. And some animals come close to it. So one option we have is look at the next slide, Daniel, to just focus on index and not worry about methane. So that's one extreme option. And we would typically select those animals in red here. And so they would have a high index, but they would tend to have higher methane EBVs, not lower methane EBVs. So that's what we would be doing at the moment. And that's not great because we want animals to reduce the methane output of our flocks. So the other option, Daniel, would be the other extreme, is just worry about methane and go as hard as you can to negative breeding values for methane. But you see already that you would actually not make a lot of progress for your index anymore, and you would not get more productive animals, which is the other extreme option, and it's probably not a very desirable option. So we need something in between, and the next slide shows that. So we need something. We want of the high index animals, probably the ones that are lower in methane, and we can do that in an index, and we would give a little bit of weighting to methane. But if you use a weighting based on the current value of methane, that wouldn't be very high. We would kind of still be selecting on animals with the highest index. But for every scenario that we plan, we can predict how much gain we make. So currently, we would make about $4.50 of profit per year per animal based on the current indexes, and methane would go up by about 0.07 grams. So that's like a few percent per year. So that's a possible scenario, and that's probably a realistic scenario, but because we put a bit of emphasis on methane, so we actually make sure that it doesn't go up too high, but it really doesn't go down yet. Still, it's important to measure methane because this is an example where if we did not measure methane, we would have a much higher correlation between the index and the methane breeding value, because the methane breeding value would just depend on the other traits that we have measured. And that gives us a lot fewer options to do anything. So you see here that the change in index is about the same as in the previous slide, but the change in methane is a lot higher. So if you compare it on the right, so the methane response can be a lot less high than if you measure the trait without losing too much index. So we should probably put a little bit of, we should measure the trait, so that helps us to not let it go up too much. It's a bit similar to measuring feed intake, and the feed efficiency can be improved by not letting feed intake go up too much. But we're not reducing methane per animal yet. But of course we could if we put more emphasis on the methane breeding value. So the next slide, Daniel. So if you put a lot more emphasis on the methane breeding value, we could go a lot faster in reducing methane. But you see here, if we did that, we start to lose index progress as well, and that's not desirable because the productivity gains that we can achieve would not be achieved. So what I'm comparing here is for different carbon prices, which kind of translates to different amount of emphasis you would put on the methane breeding value, which you could put in an index. It would lead to a certain response in index, and it would lead to a certain response in the methane. And if you go from the top, so as I said, the current carbon price is about 40. So if you made an index on the current carbon price, we would reduce methane, improve the increase in methane slightly, but we wouldn't lose much index. So we could upper that weighting on methane a bit more without losing too much index, and still reducing the methane output per animal, the progress that we achieve in there a bit less. So if you put too much emphasis on methane, if you see like $400 carbon price, then the index would go down quite considerably, but the methane per animal would go down. So we have to find a bit of a balance between those. And that balance really depends on how important is methane to us, and what is the economic value of that trait. So the next slide also shows that if you increase the weight on methane a bit more than based on the current carbon price, you would actually do quite well by reducing the increase in methane per animal without reducing the index too much. So there's a bit of an optimal point that around $100 carbon price, you would have a similar response in index and still curb the improvement, or not improvement, the increase in methane a bit. And overall, you would actually achieve a better methane intensity in terms of how much methane you produce per kilo of lamb that the industry produces. So my recommendation would be to have a weighting somewhere between a carbon price of around $100 per head or so. So that would, we wouldn't reduce productivity, but we still would handle methane a bit in the sense that it doesn't go up as much as if we didn't do anything. So the next slide asks the question, why would we put any weight on methane EBVs at all? And that really depends on what happens in the future. So we expect that at some point we will be rewarded for mitigating methane emissions in industry, and that could be in terms of carbon credits, that could be related to using low EBV animals or something like that. But that doesn't happen yet, but it's kind of expected that could happen in the near future. And then the EBV of methane really gets an economic value, which at the moment still wouldn't be very high, but we could expect possibly also that the carbon price might increase. So in that sense, if we now start with an index that puts a little bit of weighting on methane, we would probably go in the right direction. But another scenario, of course, in the future is that the government could say the industry has to just curb methane emissions, and you can't produce more than so much, which practically could simply be you have to reduce your flock size by a certain amount to do that. Well, in those type of scenarios, the best you can do is just to produce as much as possible per animal, because that kind of really maximizes the methane intensity in terms of that maximizes how much product we can make for a certain amount of methane that we are allowed to produce. So in both scenarios, it's best to have a little bit of weighting on the methane EBV because that covers us for both of the future scenarios. So we always have to remember that we would try, of course, to reduce methane per head, but the optimal solution is always to improve productivity as much as possible and to curb methane a little bit. But if you do it too much, then you lose productivity, and then actually you lose on methane intensity in terms of you're not better off in terms of how much methane you produce per kilo of land that the industry produces. So, so the recommendation, that's the next slide, is that given the tool that we have now, it's the methane EBV. If you look at the high index animals, the best scenario is probably just within that set of best index animals, just you choose the ones that have lower methane EBVs, but you don't want to compromise too much on your production index because that's actually counterproductive for mitigating methane as a whole industry. So in this, if you pick the ones in this oval here, those are animals that have a high index and a bit lower EBVs relative to the population. So you would avoid the one on the right. There's a high index because he produces too much methane, but for the same money, you can actually find other animals that do well for lower methane. Next slide. So we haven't talked much about feed intake because we haven't measured it a whole lot yet. But as we said, very soon we should have quite a lot of information on feed intake as well. And as one of the questions in the chat already said, feed efficiency and methane efficiency are very similar. So feed intake is another tool we can use to have more productive animals without using more resources in terms of feed, but also in terms of how much methane you produce as an industry. So selecting for methane efficiency, therefore, will be similar to feed efficiency. And as you can imagine, feed efficiency has immediately a higher economic value that you can actually observe. So, so the plan is to measure already quite a few animals for feed intake. As you see below that picture, we go at a quite high speed, at a quite high speed at the moment. And the plan is to measure more with the CRC, but in a way that's not fast enough. So we have proposed to MLA a project where we can work with breeders to measure faster more animals because we have now the capacity to do so. So I'm also putting a bit of a plug of if you're interested in measuring your animals for feed efficiency as well as methane, you should really contact us because we have a plan that if you co-invest, so you have a small contribution to measuring this feed intake, and then within the project we can leverage that. We're aiming actually to measure quite a few more animals in the coming years. So and there's two ways to do it. That we have a Kirby feedlot here in Armadale. But on the right of the picture, you also see an alternative way, which is a bit smaller scale, but that's a mobile facility that you can go around with two farms. It's smaller groups to measure, but we could come and visit you and use that facility. So we have a few initiatives with MLA to work with you to measure feed intake, but we need your help and your co-investment to do so. So I think we have an expression of interest more formally through the sheep genetics group, but that's our plan for feed intake. Anyway, next slide, Daniel. So in summary, so overall we want to reduce emissions for the industry, mainly to the improvement of productivity, but we measure the methane EBV, and we use the methane EBV to avoid the ones that really increase methane too much. Yeah, so it's an extra tool we can have next to the index to go in the right direction. So the weighting that we should use for methane in an index is probably a bit higher than what is the current carbon price, because that sets us up better for the future. And that would also avoid that we lose the improvement in productivity that we can achieve otherwise. So we want to basically maintain profitability and minimizing the methane outputs, and that optimizes methane intensity for the future. So there's internationally some discussion about what is the best way to present methane EBVs. Some people like residual methane, which is a bit similar to residual feed intake. That means that you present a breeding value that's corrected for production. That's not our recommendation because I think it covers quite a few bits that you cannot see then. It's more straightforward to just say, what is the productivity of this animal? How much methane does it produce? And then work with those two parameters to find the optimal way animals to select, a bit according to what I showed in those graphs before. So I think that's the last slide. Thanks, Daniel.
Excellent. Thank you very much, Julius. I think that's a really nice summary. I think for me, it really highlights, as we know, breeding is a long-term game, and we need to be thinking about that future state now and the work that's been done to collect all the records. And then now with breeding values, setting ourselves up for the future, we'll have the tools, producers will have the tools to select. But you highlighted quite nicely that this is not a trait that we select for in isolation. It really needs to be balanced with the key production and our bread and butter that we've been dealing with as sheep producers for many, many years now. So before we jump into some Q&A, and we've got one or two in the chat, but please keep them coming in. So Michael's analysis highlighted the work that's been done, the data that's gone into it. But we're really excited, I guess, to launch the project breeding values on number of key sires that have been measured in breeder flocks and also our resource flock, with those caveats that Michael mentioned. We've got a booklet that is now live on our website, which you can access via the QR code. For all sheep genetics clients, this will be being mailed out with our newsletter that will shortly hit your mailboxes around the country. And if anyone is coming along to LambX next week, Daniel, myself, and Marnie will be there, and we'll also have printed copies of this booklet at the MLA site. So please come along and get your hands on a copy. In the booklet, there's at the start, there's a bit of background, some of which we've covered today in the webinar, and then we have the sires listed with their methane project breeding values. Because of exactly the things that Julius spoke about and the importance of balancing this with production, we've also included their standard Merino Select and Lamb Plan breeding values for some key traits beside it. So as you're looking at the methane breeding value, you can start to have a look at the some of the key production traits as well. So just bearing that in mind, and some of the caveats that Michael mentioned around, really using this. If you've got some key sires measured in your flock, really using it to compare those animals with each other, and there's plenty of variation, as you'll see. So really exciting that you can now start to have a bit of a look, but remembering these are project breeding values, and we're still on our journey to create a more robust multi-trait research breeding value and ASBV. So we'll send the link after with this webinar recording, plus you can also access it now on our website. So Daniel, just on the next slide, we might jump into a couple of questions now for the presenters. So we've got one, and I think Michael, you might be a good one to chat to this one. We've got a good question here from Andrew around I guess selecting for net feed intake to help reduce methane output. Did you want to provide comment on the relationships that we expect to observe and why it's important, I guess, to have both of those phenotypes?
Yeah, we do expect there to be a strong correlation between feed intake traits and methane traits, assuming that you don't correct one for the other, as Julie's talked about. But yeah, selecting for lower feed intake should also reduce methane, but selecting for lower methane should also reduce feed intake. Basically, animals that eat more produce more methane. But also remembering that methane is a byproduct or a waste of energy. Really what we expect when we're selecting for more feed efficient animals is that less of that methane is escaping and is actually being converted into protein instead.
Great, good succinct comment there, Michael, thank you. And I see there was a bit of conversation between Rob and Hugh around actually the 0.07 grams per day. If it was 25% improvement or increase, it's actually 2.5%. So Wonderful. I forgot to mention at the start, we're joined by Julia Waite from MLA. Julia is our project manager for our research R&D portfolio from the sustainability team, and has a wealth of knowledge in all our other sustainability investments as well as our genetics ones. So thanks very much, Julia, for joining. Excellent. And just one question, maybe if there's just waiting to see if there's any others come through in the chat. Michael, I don't know if you wanted to comment, or Daniel, on the genetic correlations that you presented between methane and the other production traits. Are they in the realm of what you generally select, or what other traits have similar sort of correlations?
I would start by saying that they are within the ranges that I was expecting based on our understanding of the physiology of animals, and also from what we've seen from previous work, both in Australia and around the world. In relation to other traits, I think that methane is a good example or comparison to reproduction traits. So if we don't improve it, we could end up going in the wrong direction if we only focus on production. But it is in that, well, it's more heritable than reproduction traits, so we probably can make a bit more progress. But it's also one of those difficult to record traits, so it's a bit of a numbers game, really. So did I answer that well enough?
Excellent. That's what I was after, Michael, so thank you. We haven't had any other questions come through. So firstly, I wanted to thank all the presenters, so Daniel, Michael, Julius, for your expertise today. It's always valuable to hear it straight from the horse's mouth, so thank you very much. We will share a webinar recording, and so you can come back and refer to this if you'd like, as well as the link to that project breeding value booklet. So if you do have any questions on that, please reach out to myself or any of the sheep genetics team. And if you are coming to LambX, we'll have physical copies there if you can't wait for it to hit your mailbox over the coming weeks. So also thank you very much to everyone for your patience around having to deal with the webinar link. Got to love a good tech challenge. So thank you all very much for being good sports. Hopefully you found it valuable, and it's really exciting that we've now got project breeding values out there. So thank you very much.